Okay, let's jump right into this explainer. Today, we are unpacking a massive biological paradox. When you think of a penguin, your mind probably goes straight to ice, snow, and freezing Antarctic winds, right? Well, today we're looking at the endangered African penguin, and these guys actually call the sun-baked coasts of southern Africa their home. It's an environment that throws some seriously unique and severe thermal challenges their way. A recent study in Bird Conservation International is giving us an unprecedented look at exactly how these birds handle, or as we'll see, really struggle to handle, the heat.
So here is the multi-million-dollar question we're dealing with. How on earth does an animal built for freezing oceans survive on a 30-degree beach? It is a profound evolutionary dilemma. You've got an animal that spends a massive chunk of its life hunting in frigid waters, where staying warm is literally a matter of survival. But then, to breed and molt, they have to waddle ashore into an environment where temperatures can easily rocket past 30 degrees Celsius.
To really put that into perspective, just think about the crazy temperature gap these birds are navigating every single day. They forage in ocean waters sitting right around 10 to 20 degrees Celsius. But their breeding grounds, those routinely hit 30 degrees or more. This huge temperature swing is exactly why they are so incredibly vulnerable on land. Out in the water, their thick fat and dense feathers are lifesavers. But once they hit the beach, that exact same insulation becomes a serious liability. They're basically wearing a heavy winter parka in the middle of summer.
Now you might be wondering, why can't they just cool off? Well, the answer lies in a biological quirk called the rete tibiotarsal. It's essentially a complex blood vessel heat exchanger located right down in their legs. When they're swimming in freezing water, this system acts like a magic trick, letting them retain up to 66% of their metabolic heat. It is an absolute superpower for diving seabirds. But on a sweltering beach, that superpower turns into a potentially fatal flaw. Their bodies are just so incredibly good at holding on to heat that offloading it into hot ambient air becomes almost impossible.
Actually, historically, African penguins had a natural fix for this problem. They used to dig deep nests into thick layers of guano, which gave them a beautifully buffered, climate-controlled little home away from the glaring sun. But human exploitation literally scraped those coastlines clean of guano to use for fertilizer. That one action stripped away the natural climate buffers the penguins relied on, leaving them totally exposed to severe heat stress. It's actually a major reason why their population plummeted by a staggering 90% in the 20th century, pushing them right to the edge of being critically endangered.
Section 1. Testing thermal limits. So, to understand this crisis, researchers designed a groundbreaking lab experiment to figure out exactly when these birds overheat, completely removing the intense factor of direct sunlight. Here is how they did it. The team carefully placed 5 resident African penguins from a conservation facility into a climate-controlled room. They gave them a 30-minute acclimation period at a nice, comfortable 20 degrees Celsius. Then, they slowly, and I mean very slowly, ramped up the heat by just 1 degree every 20 minutes. The ultimate goal was to reach a max of 35 degrees over 6 total hours, which perfectly mimics the rising heat of a typical hot day inside a shaded nest.
Section 2. The Handling Stress Surprise. The team was carefully tracking the penguins' internal body temperatures the whole time. But the most shocking discovery of the whole study happened before the room even started getting hot.
39.2 degrees Celsius. That was the absolute highest internal body temperature recorded during the entire 6-hour experiment. But here's the crazy part. It happened at minute 0. Literally, right at the start of the study, when the room was still sitting at a cool 20 degrees. No extra heat had been added yet.
So what was going on? Well, this reveals a massive twist. The penguins experienced immediate severe hyperthermia, but it wasn't from the climate at all. It was a pure stress response. Just being gently captured, taking a 30-minute car ride, and being handled by researchers for 5 minutes to attach the sensors caused their bodies to massively overheat. Their core temperatures spiked entirely independently of the air around them.
And honestly, the recovery is the wildest part. It took 3.5 hours for the penguins' bodies to clear that handling stress and get back to a normal resting temp of 37.3 degrees. Think about that for a second. A half-hour car ride and a quick handling session caused a physiological heat spike that took hours to subside. It is stunning proof of how intensely sensitive this species is to human presence. Because they're so well insulated, any body heat they generate from panic is just incredibly hard for them to vent.
Section 3. Reaching the tipping point.
Okay, so once the initial stress-induced heat finally dissipated and the birds chilled out, the actual climate experiment could begin to show us their true thermal tipping points.
The researchers tracked them using what's called a thermoregulatory index, or TRI. They weren't just looking at internal temps, they were watching the bird's behavior through a window. A score of -1 meant the bird was shivering to conserve heat. A 0 meant totally neutral, normal resting behavior. And positive scores from 1 to 3 meant the bird was actively trying to dump heat, doing things like panting, lifting their little feet off the ground, or extending their flippers out to expose less insulated skin to the air.
Let's look at the timeline to see how this physical strain actually builds. At 23.4 degrees, you start seeing subtle behavioral shifts. But the critical inflection point hits at exactly 29 degrees Celsius. That is when passive cooling fails and their bodies physically start storing heat. Their core temperatures start ticking up, and by the time the room hits 31.4 degrees, the penguins are visibly distressed, desperately panting and extending their flippers just to survive the heat load.
But here is a huge reality check for us. In that shaded, fan-cooled lab, they held out until 31.4 degrees before they started panting. Out in the wild, it's a completely different story. Field observations show that African penguins out in the open sun will start panting at ambient temperatures as low as 22 degrees. Direct solar radiation basically bakes these dark-feathered birds, triggering severe heat stress way earlier than we see in the lab.
Section 4. Protecting the African penguin. So, let's tie all this data back to the real world and look at what this means for a species that is right on the brink.
Armed with this thermal profiling, conservationists can take some incredibly targeted actions. First, since we know exactly when they overheat, we can design much better artificial burrows. The data clearly shows that tunnel-shaped nests with cross-ventilation perform way better than single-entrance ceramic ones. Second, we can rehabilitate native vegetation to provide crucial natural shade. Third, and this is massive given that stress data we looked at, we have got to severely limit human and tourist disturbances, especially during vulnerable stages like incubation and molting. And finally, researchers can step back and use remote monitoring, like drones and thermal imaging, so we don't accidentally trigger a 3-hour heat spike just by trying to count them.
So, I want to leave you with this final thought to ponder. How do we balance human curiosity, our desire to study and see these animals, with the survival of a species that physically overheats just from our mere presence? It perfectly captures the delicate conservation tightrope we're walking. We want to save them, for sure, but the science is telling us loud and clear. Sometimes, the absolute best thing we can do for the African penguin in a rapidly warming world is simply to leave them alone. Thanks so much for joining me on this explainer, and I really hope it gave you a fresh perspective on the hidden day-to-day struggles of these amazing birds.